Hello guys, in this video I'm going to share a very fantastic research by Xin Li and their colleague on deconstructing denoising diffusion models for self-supervised learning. Before I take you to this model, let's see in very simple words as what is meant by denoising diffusion models and self-supervised learning. When we say denoising diffusion models, these models are a type of generative model used in machine learning, particularly in the field of image and audio synthesis. These models work by simulating a process of adding noise to data and then learning to reverse the process. The model starts with a dataset of clean, structured samples like images or sound waves. It then applies a diffusion process which incrementally adds random noise to these samples over many steps. This process gradually transforms the data into a state of pure unstructured noise. For example, just imagine that starting with a clear image and then progressively adding noise until it's completely random and unrecognizable. And then the key part of this model is to learning to reverse this diffusion process. And then there are a lot of other neural machine learning techniques involved, which I'm not going to go into the detail. Another keyword in this paper is self-supervised learning. Self-supervised learning is a type of machine learning where the system learns to understand and work with data without being explicitly provided with labeled examples during the training. It's a form of unsupervised learning, but with a structure that enables the model to effectively create its own supervision. Now, going back to the model, this is a study where the researchers have examined the representation learning abilities of denoising diffusion models, or DDM in short, that were originally purposed for image generation. Their philosophy is to deconstruct a DDM, gradually transforming it into a classical denoising autoencoder, or DAE. This deconstructive procedure allows them to explore how various components of modern DDMs influence self-supervised representation learning, as you can see in your diagram where we have denoising results. And you can, if you, for example, you look at the zebra on the top left, it is a gradual noise which is being added and then the reversal of the process. And during this, they have observed that only a very few modern components are critical for learning good representations, while many others are non essential. Their study arrives at an approach that is highly simplified and to a large extent resembles a classical DAE. And as I mentioned, DAE stands for Denoising Autoencoder. Their hope is that their study will rekindle interest in a family of classical methods within the realm of modern self-supervised learning. So really cool, and it's really good to see that they're reverting back to the fundamentals. I'll share the link to this research in video's description, and I would highly encourage you to read it if you're interested in this topic. If you like the content, please consider subscribing to the channel, and if you are already subscribed, then please share it among your network as it helps. Thanks for watching.